In the previous video, we started the process of summarizing one quantitative variable graphically or visually. So the quantitative variable we were working with was pulse rates and beats per minute. These were the data values. You could see that they are numerical or quantitative. Okay, and what we did was we constructed a frequency table. So we partitioned our pulse rates into classes, 50s, 60s, 70s, 80s, and 90s, and then we counted how many of the pulse rates fell into each class. So in this video, we are going to construct another type of graph, one that is even more sort of visual and nice than our frequency table, and that is called a histogram. Okay, and so how do we do that? Well, we're going to have two axes. We're going to have a horizontal axis, and on the horizontal axis, we're going to have our classes for our pulses, so for our data. And then on the vertical axis, we're going to have the frequency. So that will be the frequency. Okay, so let's start that process. So on the horizontal axis, I'm going to have the pulse rates. So this will give me the values for my horizontal axis. My vertical axis, I'm going to put the frequencies. Now, since the range of my frequencies is from 1 to 11, I've decided that on this axis, it makes sense to use 5, 10, 15. And on my horizontal axis, I'm going to use the my pulse rates, and I'm going to use 50, 60, 70, 80, and 90. Sometimes these are called lower class limits. Okay. I'm going to start over here. So I'm not going to start at 0 on my horizontal axis. You can if you want to, but I'm going to start at 50 occurring at this point. Okay, and now for my first class. So this class is the class of pulse rates that are run from 50 to 60, where 50 is included and 60 is not included. And so I know 50 is included because the square bracket, 60 is not included. That is, I know that because of the parenthesis. Okay, so the frequency was 1. And so to the best of my drawing ability, I am going to draw a bar at a height of 1. Now I move on to the second class. That's from 60 pulse rates that are greater than or equal to 60 but less than 70. There were 6 of them. So that's going to be slightly higher than the 5. Here's the bar for that class. And now I move on to the 70s. There were 11. So that is going to be slightly higher than where 10 is. Okay, and now I'm going to move on to the 80s. Okay, there were 5 there. So that will be about... And in my final class, the 90s, we only had 1 pulse, and so I'm back over here. Okay, and this is my histogram. So you can see that it's even more visual than my frequency distribution or frequency table. And we can see it definitely has this nice symmetric unimodal bell shape. And where the pulses start from a low number of frequencies, they increase to a one climax, and then in a symmetric fashion they decrease back down to one. So again, it has this nice sort of symmetric unimodal bell shape, which we sometimes call a normal distribution. So it seems like this sample came from a population where the pulses were normally distributed. The last thing I want to show you how to do is to create a stem and leaf plot. So for each pulse, I'm going to look at the leftmost digit in the pulse, and I'm going to use these to make the stems. So for example, in 52, the leftmost digit is a 5. For 67, the leftmost digit is a 6. And you can see as I go through these numbers, there's a 7. We see 7s, 8s. We see a 9. And I don't think there are any pulses in the 40s. Okay, but the leftmost digit gives me my stem. And then what I'm going to do, just as I did before, I'm going to go through my list of pulses, and I am going to put each of my pulses based on the leftmost digit into the class given by those stems. So for example, 52 would go the 2. I'm going to temporarily put the 2 here. And then for 67, I'm going to temporarily put the 7 here. 74, 71, 68, 67, 83, 74, 75, 67, 98. We have 84 here. 72, 73, 71, 73, 72, another 72, 74, 64, 65, 82, 85, 89, and that is it. And so my final step is I'm going to arrange these numbers, which are called leaves, from in ascending order. Okay, so let me do that next. So here are my stems. I have 5, 6, 7, 8, and 9. And so there's only one value here, so I'm going to write the 2. Over here you can see the smallest value is 4. And then I have a 5. I have 3 7s and an 8. Smallest value in this corresponding to this stem, I have 2 1s, 3 2s, 2 3s, 3 4s, and I have a 5. For the 8s, we have 2 3 4 5 9. And for the 90s, we have an 8. So this right here is what we call the stem and leaf plot. So we use the leftmost digit, and then we is our stems, and then we use the right digits for the leaves. And this is just another way to visualize data. Once again, you can see that most of the data values are in this class. Okay, and then we have that symmetric bell-shaped pattern. And if you were to, if I was to rotate the page, so let me just do that. So once I rotate the page, you can see that this sort of looks like my histogram, right? So let's take a look back at the histogram we had here. It's got that same shape. Okay. So the stem and leaf plot is kind of like a histogram, but the nice thing about the stem and leaf plot is that we actually we keep the values, right? So I can recover every value in my sample from the stem and leaf plot. So it has this advantage that in addition to having showing me the shape of the data, it also encodes all the values in the stem and leaf plot. Okay, because remember with the histogram, once I look at the histogram, I sort of lose some information. Like I don't know, I know that there were 11 values in this class. However, I don't know exactly what those values are without the list of data values.